Okay, I'm gonna go over October 8th test. So let's go through. All right, first things first. This is gonna take a little while because I have to play with this number. This answer here is x to the power of 6. And the rule here is, oh, come on. All right, let's keep going from here. The rule here is you keep the bases the same and add the exponents. So we kept the x the same, add the exponents. Now here is a divide, it just didn't print out. The answer to this one is y to the power of 9. So this rule, keep the bases the same and subtract the exponents. Now power of a power, this is going to be 2 to the power of 15. And here, the base stays the same and multiply the exponents. So I went 5 times 3 there. The answer here is 1. And the reason there is because anything to the power of 0 is equal to 1, no matter what number it is. The answer here is 1 over 4 to the power of 4. Now here, if you flip to make positive. So if it's 1 to the power of 4 to the negative 4, if you take the 4 negative 4 to the bottom, and it becomes positive. All right. So, example of a linear equation. Example of a linear equation, let's say, is y equals 2x. The key there is the exponent has a 1. And the exponent on the x is 1. Table of values, the first differences are the same. And a graph would kind of look like this. So there's my Cartesian plane, and I'm going to put in a line. Let's make it a different color. As such. Good. Now, quadratic, we know that the exponent has to be a 2. Good. And then the second differences are the same in your linear equation. And then if I draw it, the graph here, it would look something like this. One second. My wife is currently cleaning up some kind of random cat thing that happened. Okay. The cat got up behind our TV. Alright, back to the test. Exponential, y equals 2, and now the exponent is the variable. Like such. There's an example. And here, second differences have a pattern. That's what we're looking at. Now if I were to draw something, example of one, it might kind of look like this. As such. And go up. Alright, there we go. Let's apply these rules we had here. So, taking a look at this one, this is a power of a power. the one thing I have to remember here is there's a 1 right there. Oops. There's a 1 right there on top of the 2. So my second one here, my second line is going to be equal to 2 to the power of 4 2 to the power of 4, I gotta keep jumping back and forth here, x to the power of 12, and y to the power of negative 16. Now you know you want me to leave the exponent positive, so I'm going to make that positive over there. So what I'm going to do is I'm going to copy this part, so I don't have to retype it, and then we're going to put this all over y to the power of 16. So that over, and then y to the power of 16 here. Now that's positive. So there's my final answer. Now here, all I have is multiplication. Here, so let's just multiply everything together. So now I don't have similar bases, so I'm just going to multiply it. So that's going to be 20, x to the power of, and I'm just going to add these, x to the power of 7, and y to the power of 2. Since both of those have 1s on top, it's going to be by the power of 2. Now, this is all going to be over top of whatever my answer is for below. Now, if we remember, anything to the power of 0 equals 1. And all this is the power of 0, so it's just going to equal 1. And then we're done. Now here, we're trying to solve the equation up here, but if we look here, we have the same base. So once we have the same base, we can just drop the bases since they're equal. And we're going to be left with x minus 5 equals, I think cover it up, 4x plus 40. Now we rearrange it. So I'm going to leave the 4x here. I'm going to leave the 4x on this side. So I'm going to bring over my x, which is positive, which will become negative. And this side, I already have a negative 5. I'm bringing the 40 over, so it's going to be negative 40. Then that'll equal negative 45 equals 3x. Then I'm going to divide both sides by 3 to get negative 15 equals x. Now let's just go like this so we know what's going on. Divide by 3. Oops, that's a horrible 3. Divide by 3. And those will cancel out. And there we go. Now here, we don't have similar bases. So we need to make a similar base. So let's write this one here anyways. Let's go 8 to the power of, what's up there? X plus 10? Oops. To the power of x plus 10. Now we need a similar base here, right? So we have 8. So let's figure that out. So we just plug in 8 into our calculator, and let's go take a shot at 3. Oops. 8 to the power of 3 equals, well, 512. So we're going to replace this with 8 to the power of 3. And there's our similar bases. And now since we have similar bases, we can drop them. So we got x plus 10 equals 3. Then we rearrange, so we get x equals 3 minus 10, so x equals negative 7. And that one's done. Alright, so now let's take a look at this one here. So let's label what we have. I'm not going to make my chart here because it'll take me too long. Here's my angle, so there's my theta. Now this is my hypotenuse, since it's across from 90 degree, and this here is my opposite. So I know I have opposite and hypotenuse, that's going to be sine. So that's going to be sine 43 equals opposite over hypotenuse. I didn't do theta because I have no clue where the theta button is on this. So sine 43 equals x over 22. And once we rearrange it, we're going to have 22 times sine 43 equals x. If we plug that into our calculator, 22 times sine 43 equals 15. 15 equals x. Let's take a look at this one. This here is my theta. This here is my opposite. This here is my adjacent. So I know I'm going to use tangent. This is sine. Alright, so let's take a look. Start writing over here. So we have tangent equals opposite over adjacent. If we plug everything in here, we have tan x equals 34 over 42. And 34 over 42, 34 divided by 42 equals 0.81 approximately. So tan x equals 0.81. Oops, 81. Then I need to get rid of the tan, so it's going to be actually x equals tan to the power of -1, 0.81, and that will equal 39 is my answer. X equals 39 is my answer there. Now here, looking at the population of Mattyville, Ontario, can be modeled by the following equation, where T is the number of years since 1990. What is the population of Mattyville in 1990? Well, since this format happens at 1990, that means this right here is our original amount. So our original population is 6191. So is it growing? Well, we know it's growing because this number is above 1, right? So let's write that down first. It's growing, and by 4%, because that's how much higher than 1 it is. 1's our base, then we take 0.04, and we would go, since we're going from decimal place to fraction, we go 0.04 times 100 equals 4%. So what is the population of Mattyville in the year 2000? Well, let's plug everything into our formula. So 6191 bracket 1.04 bracket to the power of, this is where a lot of people had a mistake here. So in 2000, so that's 10 years later than our original formula. So it's going to just to the power of 10. I highly doubt this can run the numbers. It didn't, so let me do the pop calculation here. 6191 1/4 bracket to the power of 10 equals 9164 is our population. Alright, let's go here now. So simplify this equation. So here, we have a multiply here first. So let's just multiply these together. We're going to deal with this -1 after. So 4 to the power of 5 times 4 to the power of 1. Remember, there's a 1 there. So this is going to be 4 to the power of 6. And then x to the power of 2, x to the power of 7, add those together, is going to be x to the power of 7. And this is to the power of -1. So, and then let's bring that in to the brackets. So we know that we're just going to change the signs of these, which of course I can't do easily, so I got to type it in like so. And then we also know that I also like everything as a positive, so we're going to flip it. We're going to go 1 over that, and there's our answer. So first we multiply them, then we bring in the negative 1 in multiplication, then we make a positive by flipping it. Now here, we need to find out what that x is, but we don't have a similar base right now. But we have this 11 just hanging out there. So let's get rid of that. And what we do is we divide this by 11. We divide this by 11. So let's do that calculation first. 14256 divided by 11 is going to equal 1296. 1296 equals 6 to the power of x. So now we need a similar base. So we have a 6 on one side, so logically it's going to be 6. So just start playing with your calculator, and let's go 6 to the power of 4. Well, what do you know? We got the right number. Don't want to write stuff down. Good. Now since we have similar bases, we can drop it. You got x equal 4 equals x. Now this one here, we need similar bases too, but 16 can't be a similar base to 64, since 16 squared, which is like lazy and go, is 256. So we need to find a similar number. So I bet it's going to be 4, since 4 squared equals 16. So 4 to the power 4, nope, 4 to the power 3 equals 64. So let's start off by that. So we go 4 to the power 3 equals 64. So we just rewrote the number. Now what's already up there is the x, so we need to leave the x up there. And then equals 4, as I said before, squared. Now what's already up here is the x minus 2. So now that we have similar bases, we can go from there. Let's drop the bases. So we have 3 bracket x equals 2 bracket x minus 2, which is going to equal 3x equals 2x. And this is where a lot of people got wrong. They wrote negative 2, but you have to rainbow that into both sides, so it's negative 4. Let's rearrange. Minus 2x equals negative 4, and so x equals negative 4. So the key there, which a lot of people got tripped up on, is we didn't rainbow in here and here. Alright, so let's take a look at this. Elizabeth and Nicole are on different boats on either side of a treasure chest. Each has a rope attached to the boat. Let's have some fun here. Let's go. I wonder if I can do this. Paste it there. Oh, it's going to paste somewhere weird. Nope. Oh, come on. Never mind. I can't do what I want to do. Alright, so let's sketch out the diagram here. So we have 2 boats. So I'm going to make a boat like so. Let's make these boats. Okay. Each on different sides of the treasure chest. Let's draw a little treasure chest, red. Let's go X marks the spot. Right there. Each has a rope that's attached to the treasure chest at the bottom of the lake. So this one has a rope, and this one has a rope. Bottom of the lake, 15 meters below the water. All right. So and then I know. Let's say this is my water. There we go. We know that this here is 50. Elizabeth, let's label this one E for Elizabeth, has an angled depression of 40 degrees. So 40. And on Nicole's is 68. Good. How far are the boats apart? All right. So let's look at Elizabeth's triangle first. So let's redraw Elizabeth's triangle only. So I have this, this, and this. So this is 50, and this is 40. And we're looking for how far the boats are apart, so we're looking for this. Okay, so since we have that, we have the adjacent, we have the opposite, and we have theta. So that means we're going to use tan. So if I write this out here, I have tan x equals opposite over adjacent. So tan 40 equals opposite is 50 over x. Now we need x all by itself. This is where a lot of people got messed up. So let's rearrange it. So x is currently on the bottom. We can't have that. So we got to move it over to the side. So it's a divide on this side, so it becomes a multiplied on this side. Then we need x all by itself, so let's move the tan over. So right now tan is a multiply, so when it moves over, it's going to become a divide. So 50 divided by tan 40. So essentially those two just swap places. And let's run our number. 50 divided by tan 40 equals 60 degrees with rounding. That means 60 meters, 60 units, whatever we have. So let's draw out my other one. So this one over here looks like this, with 50 and 68. So this is my adjacent, opposite, and my theta. So we're going to use tan. Therefore, I also have tan x equals opposite over adjacent. So my tan x, sorry, it's not tan x, it's tan 68 equals, my opposite is 50 over x. So that's what I'm looking for. And this time I'm just going to flip them. So we already saw it on the other side. And then we go 50 divided by tan 68 equals 20. So how far are they apart? Well, it's 60 plus 20 equals 80. And then we have a nice statement. Dot, dot, dot. Therefore, the boats are 80 meters apart. So St. James, which has a population of 5 hotels, has been overrun by zombie apocalypse. Each day, half students return to zombies. How many students remain after 6 days? So this is exponential decay. So let's write our equation for that. So let's say students would be S. Our original population is 512. Then it's going to be a decay, so it's 1 minus, and it's half, so we're going to minus 0.5. And then we're going to put it to the power of days. So since it's 1 day, we cut it in half. So then let's do this calculation again. This time I'm asking you for 6 days. So we're just going to plug in that. And we can simplify this by just 0.5. So if I run that number, the power of 6 equals 8 students. So unfortunately, after only 6 days, we only have 8 students left and the rest are zombies. This one here I'm not going to show yet, because there's still people who are going to continue quizzes, and I've changed questions, but this question is still the same, so I'm not going to record that one yet. I'll take that one up in class. Okay, hopefully that helps you, and have a great day.